Welcome back, friends. In this video we are going to discuss the concept of vapor pressure in relation to boiling point, and then we will move to the two component liquid system. So as we said in the previous section about the vapor pressure and the saturated vapor pressure, the temperature at which the vapor pressure is equal to the atmospheric pressure is called the boiling point. Ndio maana nilikwambia kwamba tunafunika liquids ambazo tunazichemsha ili tuweze increase the vapor pressure. If the vapor pressure is increased to the atmospheric pressure in a very few seconds, that means the liquid will boil in a very few seconds. Kwa hiyo ili liquid iweze kuboil lazima vapor pressure yake increase to the extent ambayo vapor pressure will be equal to atmospheric pressure. So at the boiling point, the vapor pressure of the liquid is equal to the atmospheric pressure, that is external pressure. So if the liquid has a higher vapor pressure, then it needs low temperature to increase its vapor pressure to become equal to the external value. Kwa maana liquid ambayo ina high vapor pressure au liquid ambayo ni more volatile itahitaji pressure kidogo tu ili tuweze increase ile pressure ifikie ngapi? Ifikie atmospheric pressure. Hence low boiling point of the liquid. And so the higher vapor pressure implies low boiling point, and the lower vapor pressure of the liquid implies high boiling point. In other words, the boiling point of the liquid is inversely proportional or varies inversely proportional to the vapor pressure of that liquid. And then from there, let's discuss about the concept of two-component liquid system. Tunaposema two-component liquid system, tulielezea concept kwamba inakuwa ni liquid ni solution ambayo imekuwa formed by the mixture of two liquids. So a solution prepared from two completely miscible solvent au liquids. Hiyo ndio tunayoanza nayo. Later tuta discuss zile solution ambazo haziwi miscible. Tuanze na miscible. The complete miscible liquids form a solution when mixed together, based on intermolecular force of attraction between the molecules of the pure solvent and the intermolecular force of attraction between the molecules in the solution. Hiyo tunasema kwamba the solution which is formed by mixing two miscible liquids are classified into two major groups. Tukibase kwa nini? Kwenye intermolecular forces of attraction. Kwa tuone kwamba the first group is called ideal solution and the second group is called non-ideal solution. Lakini zote ukumbuke they are miscible. They are completely miscible. So what is the ideal solution? What is the non-ideal solution? Haya, tuanze sasa. An ideal solution is the solution formed from completely miscible liquids whose intermolecular force of attraction are equal to the intermolecular force of attraction of its pure liquids, and such solution obeys Roots law. It is very important to define ideal solution. Hii unaidefine kama ilivyo. If the solution formed from completely miscible liquids whose intermolecular force of attraction are equal to the intermolecular force of attraction in the pure liquids, and such solution obeys Roots law. Hii tunaita Roots law. So roots usio kaandika roots ya mizizi. No, inasomwa inaitwa Roots law. Na unaiandika hivi RAOULTS law. What is the Roots law? To discuss mbele. Now, that is the ideal solution intermolecular force of attraction which is equal to the intermolecular force of attraction in pure solvent before they mix. Kwa hiyo kwenye demonstration we can demonstrate our information as tunaweza kaziandika katika sura ambayo tukasema A ilifanya bond na A mwenzake. This is the pure liquids. Then this is equal to B. Kwa pure liquid A na pure liquid B zina bond ambazo zinafanana. Lakini not only that, but also this is equal to bond between A and B. This is a bond in solution. So the bond in solution imekuwa equal kwa sababu gani? The bond between A is equal to the bond between B. If this bond is equal to this, that means if we mix them, then bond ya kule mwishoni itakuwa nayo ni equal. So tunachokisema ni kwamba intermolecular forces of attraction, intermolecular forces of attraction of impure liquid A, forces of impure liquid A, we don't have again forces of intermolecular force of attraction in pure liquid A, in pure liquid B. So yeah, this is the labeling of the diagram. The labeling of the diagram: intermolecular force of attraction in pure liquid A, intermolecular force of attraction in pure liquid B, and this is the intermolecular force of attraction in the solution. So from there, we are saying that ideal solution obey Roots law over all concentration range at a given temperature. So this is not off. It obey Roots law over all concentration range at a given temperature. The two liquids on mixing form ideal solution when. Kwa hizi hapa nazita characteristics of liquids ambazo zinaweza ka form ideal solution. Characteristics of liquids which can form ideal solution. Kwanza, both they must have similar structure. Kwa maybe tuna methano na ethano. All of them they are alcohol, similar structure. So always hapo unaweza kukuta kwa mfano tuna benzene labda na tuna benzene alafu tuna toluene, kwa sababu kwenye structure anawaonyesha tu, this is organic chemistry. Kwenye structure benzene will appear as while toluene will appear as CH3. So this is benzene and this is toluene, or sometimes it is called methyl benzene. Kwa hiyo unaweza kuona tu ni kwa jinsi gani ambavyo huyu na huyu wamefanana hapo. Kwa kwanza lazima ziwe zina similar structure, sio the same, similar. Then both have similar nature au polarity such that both are polar liquids or non-polar liquids. Kwa lazima ziwe zinafanana, either they are all polar or they are all non-polar. Lakini tatu, both have identical intermolecular forces. Forces zake of attraction lazima ziwe zinafanana, jinsi ambavyo kuna attraction inafanana kama ambavyo tumedemonstrate. Lakini nne, both have approximately similar molecular size. Molecular size yani molecular mass zake ziwe zinafanana. Hiyo hizo component ndo zinazikatengeneza nini? Ideal solution. So let us end up here. In the next session tutaanza kudiscuss behavior of ideal solution. Hizo tuzo discuss ilikuwa ni behavior of liquids which can form ideal solution, but not behaviors of ideal solution itself. So in the next session we will discuss about the behavior of ideal solution itself, not the liquids which mix to form the ideal solution. Don't forget to subscribe and to share the link of this video. Don't forget to like it, and don't forget to join my Telegram group for more discussions and more clarification. Thank you everybody. Let me wish you nice studies.